Hey everybody, it's Chris from the Droning Company here with Bryan Baker of Leica Geosystems. Bryan, this is quite the setup that you've got here. I mean, you've got everything from this really high-tech looking drone to a robot dog, if you will, walking around your booth. Tell us a little bit about your company and the types of solutions you put out there.
Thanks, Chris. Leica Geosystems, we've been in business for 200 years. We're a surveying and construction measuring company, a geospatial company. Of course, 200 years ago we didn't have electronics, and so we were making things like very accurate tape measures and what are called transits and theodolites and that sort of thing. But of course, with the technology, we've moved into the automation of data collection. And what you see here is our autonomous reality capture portfolio. So the way that traditional measuring has been done is people will take out a tape measure and maybe something to measure angles and distances, and then they'll go out and they'll make their discrete measurements. With reality capture, what we do is we go out and we just capture everything using LiDAR, imagery, a variety of different methods to just capture everything that's out in the field, bring it back, and then we pull what measurements we need and what data we want out of the data that we've collected.
Okay.
So that's the difference in traditional measuring of structures and features versus the way we do it with reality capture.
Okay.
So it takes the field time and really shortens it up, because we just can now, instead of making 300 or 400 measurements over the course of a day, we can fly a site in 45 minutes and then have all the data and then decide what we want. Okay. And if there's something that they didn't get with a discrete measurement, they'd have to go back out and get it. We don't have to do that. We've got everything. So we can just say, oh, well, we really wanted to measure this, and we just have the data there.
That's amazing.
So that's kind of the concept behind reality capture, and is what this product portfolio, whether it's the BLK to fly or the BLK 360 or the BLK ARC, is designed to do. So different tools for different applications, and depending on the application, you just select the right tool for the job. There's some things that you can't do with a drone. For example, let's say you're in downtown Manhattan. Can't fly a drone in downtown Manhattan, all right? So if you have our other tools, there's a lot of things that you can do. Obviously, you're not going to be able to fly, 100 stories up and get that data, but we do have those tools to be able to get the data in other methods.
Okay.
So
now, you were talking about how this portfolio works together in terms of getting the measurements that you want. So tell me, does everything have to be at the same time, or is it put the drone up, get the data with the drone, and then take that device back there in the corner and go in, at a later time?
Yeah, we can do it at completely different times.
Okay.
What you have to be careful of is that the scene hasn't changed dramatically, in those different times. And so if you have a commercial construction project where you've got skid steers and loaders and things like that, that equipment's moving around, we can filter that stuff out. But if you fly a building and then you put a second floor on it and then you do the ground collection with it, you're going to have some differences in the data. They're not going to line up. So you want to try and capture the whole scene as in a short a time frame as possible so that everything is consistent across the data set. But the systems do work independently. For example, 3 months ago I was here in Vegas and we're over at the Venetian, and I scanned the outside and the roof with the BLK to fly, and then a couple hours later I went out and got the underneath of the car parking area with the BLK to go. The scene hadn't dramatically changed. It wasn't an active construction site, so it wasn't a big deal, and the data just lined up perfectly.
Now, in terms of the data lining up, do you have a software solution that you can pair with these, or is there another solution that pairs well with it that might be a third party?
So our software solution for the BLK products ingests the data from all of our sensors.
Okay.
So whether it's even our higher end RTC series or our P series, that data can be integrated and meshed with our to-fly data, so that you actually get a complete three-dimensional point cloud from our entire product portfolio. And in fact, we can even ingest data from other systems. So if you had something as simple as a DJI Phantom that had created a point cloud from Drone Deploy, we can take that point cloud from Drone Deploy and combine it with the point cloud from our To Fly in our software.
That's amazing. That is very cool. And talk about just like versatility, because I know there's probably companies out there that need something like your to-go product, but they already have the DJI Phantom with the RTK unit, so they don't necessarily need a drone solution. So that versatility is fantastic.
Right.
I do want to talk a little bit about two products I see here.
Okay.
We'll start with the drone, because I think most of our viewers are going to really appreciate this.
That's why we're in Vegas. It's
Exactly.
the commercial UAV Expo.
Exactly. So tell me some of the specs on this. I mean, in terms of flight time, in terms of power, that's incredible. That's great. Very portable, I see.
Portable, easy to use. So there's a lot of tech packaged into this drone. There's no payload because it's all integrated.
Okay.
So first we have the LiDAR sensor that's on the front of the aircraft, and it's aligned along the longitudinal axis of the aircraft.
Okay.
So it's scanning 360 degrees this way by 270 degrees this way.
Okay.
Which means that as it flies over a vertical structure, it's actually getting the back side of it in the same pass.
Okay.
So you don't have to make multiple passes over the structure. 420,000 points per second that is scanning.
That's phenomenal.
And it has 5 cameras on it. We have a right, forward, left, top, and bottom camera. So while it's flying and while it's scanning, it's collecting a panorama image, 8 megapixel panorama image every 2 seconds. And that image is used for colorizing the point cloud once it dumps into our software.
Okay.
The cameras are also used for flight stabilization as part of the SLAM algorithm, and they're also used for the pilot to be able to see what the drone sees.
Okay.
So where we don't have the LiDAR is also part of our obstacle detection and avoidance. We have radar sensors on the side and on the rear of the aircraft that will detect obstacles down to 1/4 of an inch.
Wow, that's
so
very accurate.
you can't back it into a building or a pole or even a 1/4 inch cable. It'll detect it and it'll just stop.
That's amazing.
With the LiDAR, when it detects an obstruction, if it's in its flight path, it uses the LiDAR in the flight controller's AI to figure out if it's better to go around that obstruction or up and over it.
Okay.
So from a piloting standpoint, it's super easy to fly. If you know how to operate a smartphone, you know how to fly the BLK to fly. We have gesture controls, so on the tablet, when you swipe to the right, the aircraft rotates to the right.
Oh, okay.
When you swipe to the left, rotates to the left. When you pinch to zoom in on the video, it flies forward, and when you pinch to zoom out, it flies backwards.
That's amazing.
When you double tap anywhere on the screen, it flies in that direction X number of feet that you set up in the settings, or until it detects an obstacle, at which point it'll stop.
Okay.
In the 3D view, the pilot actually can see some of the LiDAR data to know if they're getting the entire object that they want to scan. And in that 3D view, a pilot can tap on a point and the aircraft will just fly to it. So if it's on the one side of the building and you tap a point on the other side of the building, it'll go around the building or up and over the building, depending on what the AI says is the shortest route, gets to that other side and continues scanning.
That's cool.
So to capture a surface, all you do is using those gesture controls. There's also virtual joysticks, so you can fly it traditionally.
Okay.
You simply point the aircraft at that structure and you tap points to define a boundary around where you want and you hit go.
Okay.
That's all you do.
In terms of operation of this, I understand you have an autonomous system, you have a manual system. I mean, more often than not, is this going to be flown with an autonomous programming ahead of time, or is it going to be manually flown?
So the flight planning is all done in real time. So there's no real advanced flight planning because you just point the drone at what you want to collect, draw a polygon around it, and it goes and gets it.
Okay.
So, there's really no advanced flight planning. About as advanced as we do is just to check the airspace that we're going to be operating in to make sure that we're regulatorily compliant, and the software checks that for us automatically. Regarding the aircraft itself, there's no restrictions on where it can fly.
Okay.
It's all up to the pilot and command to have the proper authorizations and waivers or permissions, whatever they need to operate.
And I found that's a trend that we're seeing in the commercial industry is ridding the drone of that geofencing, that predetermined geofencing, and putting the responsibility on the pilot, which I think most commercial pilots really appreciate.
Well, that's where it should be.
Yeah.
And that's where it is for all of the rest of aviation.
Yeah.
So the pilot and command, the difference between drones and manned aviation is that anybody with a few $100 can go buy a drone. Not anybody with a few $100 can go buy an airplane and fly it.
Right.
So the companies came in and were protecting people from themselves, basically, who didn't know what they were doing. But someone who's spending, the amount of money that they're spending on these systems that are in here, they're not, yahoos that don't know what they're doing.
They're going to take it seriously.
They're going to take it seriously because they're insured and they're certificated. So, they don't mess around, which is why we don't feel that there's any responsibility on us to dictate where the pilot can or can't use the system.
Yeah, I think that's a great outlook, especially for your platform. Now, last part I want to ask you about, then we got another question. The RoboDog. I got to know. So in terms of what your company does and the solutions you provide, I mean, what would an application like that, where would you use that?
Anywhere you don't want to go.
Okay.
All right. So there's plenty of places where you don't want to put yourself or your employees at risk, whether it's been in a fire scene, so a collapsed roof, whether it's a homicide investigation, whether it's a tunnel, whatever it happens to be, when it's at risk of personal injury or a nuclear facility, for example, where you can't send anybody into it, we send in an automated collection system.
Okay.
And so what you're seeing on
Can we go over and look at it?
Yeah,
let's
sure.
go on over.
This is the BLK Arc.
Okay.
And the BLK Arc is really just the sensor that's on this robotic dog.
Okay.
The robot is made by Boston Dynamics. It's one of our integration partners that we have. But the BLK Arc, the LiDAR sensor on it, can be integrated with most any robotic carrier. So maybe a quadrupedic dog is not the ideal tool for your particular application. Maybe you need something that has a tracked vehicle, or maybe you need something that's going to be in a slippery environment with mud and things like that. So we can actually integrate our BLK Arc LiDAR sensor with whatever robotic carrier is appropriate for the job.
Okay.
So this just happens to be the one that we first integrated with. And there's some really cool capabilities because not only is like the BLK to fly, it's actually feeding navigational data to the dog.
Okay.
So the dog is learning about its environment. So then we can send the robotic dog into an area that we don't want it to be in personally, and it'll go and completely collect all of the data in there without any input from us.
That's amazing.
Or we can do something like schedule a certain route that we want it to take. If we have a manufacturing facility and the people at night go home and we want to scan where things are in the middle of the night, we can send it out autonomously at a fixed schedule and have it get the data, and next morning when you come in you can see where everything was.
That's amazing. The technology. I mean, when I walked in and I saw that walking around, I knew something like that existed, but it startled me because it has such a fluid movement. I mean, in terms of exploring those dangerous or not so safe places, I mean, how effective is it? I mean, do you ever have any mishaps with it where it breaks down and somebody needs to retrieve it, or?
Well, there's certain environments that just aren't conducive to it, and if there's a patch of oil on the ground, you and I are going to slip on it and break our neck,
right.
And the dog will slip on it also. So there's certain environments, but the dog's capable of. We call it a dog. Everybody does. It looks like a dog, and people want to pet it and take selfies with it. So it'll go upstairs and downstairs, but it has a lot of sensors in it that detect movement, and so it's got proximity sensors in it and that sort of thing. But it has to be the right environment for it. It's not designed to go walking in the water. It's not really designed to be in tall weeds and things like that because it detects those as actually obstacles, and it's like.
Then it has a meltdown, sort of. Not a meltdown, but it freaks out a little bit. It's like, I don't know what to do.
Yeah. And putting it in an elevator and going down with it also,
Oh, really?
Yeah.
Interesting.
The accelerometers in it think that the dog thinks it's falling.
Okay.
So the dog's having like a bad dream, like you're falling and you wake up. It's like, ah! So
that's amazing. That is just amazing technology. Last question, okay? if somebody that was trying to get into the commercial drone space, whether they're getting in for mapping, inspections, whatever the case may be, but they don't know where to start, if you had one piece of advice for them, what would it be?
Focus on your expertise and then apply the drone to your expertise. Do not try to take a drone and then figure out what the expertise is, because drone technology and any of this technology is pretty useless if you don't know what you're needing to collect, okay? And so I've had people tell me, I want to get into geospatial mapping. It's like, well, do you know anything about ground control points? They're like, huh? So, so teaching someone how to operate a drone for the expertise that they are already familiar with, whether it's construction, whether it's survey mapping, whether it's forensic measurement, whether it's plant, tank inspection, that sort of thing. It's much easier to teach a person how to operate a drone who has the expertise for what they're trying to collect than trying to teach someone who knows how to operate a drone about what's they need to collect.
Sure.
I've had, I don't know how many people come to me and say, oh, we hired this drone provider, this drone guy who had a Mavic to come in and scan, take pictures of something for us, and all the data was garbage. And it's because, the other 5 days of the week, the guy's doing wedding photography or something silly like that. So not silly, but you know what I mean.
Yeah,
something
not within
unrelated to what that is. So that's the biggest piece of advice I give to all people who ask me about being a drone pilot and what they can do. So, and most people are coming from an area of expertise already in something.
Yeah.
So you just figure out a way to incorporate drone technology into what you're doing. A great example of that is a guy I was with last week. He was a construction superintendent, and he was really interested in drones, and he started using drones for his construction site, and the management was like, oh, that's really cool. And so he said, yeah, look at what we can do. And they saved thousands of dollars every week just by him capturing the aerial imagery and putting it all together for them to be able to realize where their assets are, where the project is in progress, and that sort of thing. And so that's how that applies. Whereas someone who just knows how to take pictures is not going to capture that information.
Sure. I think that's really solid advice. Last thing, people want to learn about Leica. They want to learn about what you do. Where can they find you? Social media, websites, where's the best to go?
BLK 2021 is the autonomous reality capture website for this entire portfolio of products. And LeicaGeosystems.com is our company portfolio for all of our other measuring products that we do. We have mobile scanners that go on vehicles. We have airborne scanners that mount in planes. We have land surveying equipment. We have GIS equipment. We have laser rangefinders. So a whole basket, hundreds of different products that are for particular applications.
That's awesome. Bryan, thank you so much for your time. Really appreciate it.
Pleasure, Chris.
Yeah, thank you.
Enjoy the show.
You too.
All right, thanks.
The Droning Company is a job agency for drone pilots which also incorporates a high-end magazine about the industry. So people search this when they're looking for a drone pilot. They talk to the pilot directly, either via email or phone. We're not involved, we don't take commissions. Never have, never will.